Hi guys, welcome back to YouTube channel Chemistry Live UGPG. So today we are going to talk about determination of composition of unknown acetic acid solution by surface tension measurement by number method. So this will be highly beneficial for BSc and MSc chemistry students. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So there is a disclaimer for this experiment. So in this experiment, approximate data are used to give a flavor about the real experiment, calculation part and conclusion, and better understanding about the experiment to the students. So if you carry out your own experiment, you will get your own original data, and it may happen that the result may vary from person to person. So let's talk about the aim of the experiment. Determination of composition of unknown acetic acid solution by surface tension measurement by drop number method. So what are the apparatus required? So we need stalgamometer, specific gravity bottle, measuring flask, a small rubber tube with screw pinch cork and weighing machine. So here are the apparatus. So this is known as stalgamometer, specific gravity bottle, this one is measuring flask and this one is weighing machine. So what are the chemicals required? We need distilled water, acetic acid, chromic acid and alcohol. So this is the theory behind this experiment. So basically what happens in number drop method, the number of drops formed by equal volume of two liquids are counted. And this number of drops are related to the surface tension of the liquid and the density of the liquid. And this is the relationship, and this equation tells how surface tension is related to number of drops of each liquid and density of the two liquid. So if one liquid is water, so its surface tension and density are already known. So the surface tension of unknown or acetic acid solution can be calculated by using this equation. So this is a very simple experiment. So now question arises how to make different percentage of a solution. So there are different methods. We can make the solution by weight percentage. So weight by weight percent solution. So we have to use this formula, weight of the solute by total weight of the solution into 100. So suppose we are interested in making 5% weight by weight acetic acid solution. So what we have to do? We have to take 5 gram of acetic acid by using the weighing machine, and that we need to transfer into the volumetric flask, and the total volume of the solution should be 100 gram. So in that case, so since we have added 5 gram of acetic acid to the volumetric flask, so we need to add 95 gram of water, so that the total mass of the solution should be 100 gram into 100. Similarly, the solution we can also make volume by volume percent. So this is the formula, and suppose we want to make 5% volume by volume solution. So in that case, what we have to do? We have to transfer 5 ml of acetic acid to the volumetric flask, and in this flask the total volume of the solution should be 100 ml. So in that case, we need to add 95 ml of water to make up this volume, and up to this mark, so the lower meniscus should touch. Similarly, another way we can make weight by volume percent solution. So this is the formula. So weight of the solute by total volume of the solution into 100. Suppose we want to make 5% weight by volume acetic acid. So in that case, we have to take 5 gram of acetic acid into the volumetric flask, and the total volume of the solution should be 100 ml. So here, since we have taken 5 gram of acetic acid and we know the density of acetic acid is 1.05 gram per ml. So we can calculate the volume by using this rho equal to m by v relationship. So it comes to be 4.76 ml of acetic acid. So then you need to add only 95.24 ml of water, so that the total volume of the solution should be 100 ml. So in that way we get 5% weight by volume solution. So now let's discuss what is the procedure we need to follow for this experiment. So the stalgamometer is cleaned with chromic acid mixture, then washed with water, and it is dried. So this is the picture of this instrument where the surface tension we can find out, and we can count the number of drops by sucking the solution through this. So this is called stalgamometer. And a small piece of rubber tube. So this one you can see here, having a screw pinch cork attached at the upper end of the instrument. And the lower end of stalgamometer is immersed in distilled water and soaked water 1 to 2 cm above this mark. So here there will be a mark. So you have to soak the solution above this mark. And the tube is so adjusted that 10 to 15 drops fall per minute. Then the stalgamometer is clamped and water drops are allowed to fall and start counting the number of drops. When the meniscus crosses upper mark A, and stop counting when meniscus passes mark B. So at the bottom also, just below this here you have a mark so that just when the solution comes here, you stop counting the number of drops. And this process is repeated, and the stalgamometer is rinsed with alcohol and dried. Then what you have to do, you have to take the acetic acid solution of a different composition that you have to prepare, and it is sucked and number of drops are counted similar as in case of water. Then a clean and dried specific gravity bottle. So this is the specific gravity bottle, how it look like, whose volume is 10 ml. And weighed with water as well as different composition of acetic acid, and the temperature is also noted. So this is the procedure, very simple experiment but time taking. So here is the observation. So room temperature recorded 27 degrees Celsius and surface tension of water is 72.75 dyne per centimeter, and weight of specific gravity bottle is 11.9 gram. And this is the equation that we need to use for calculating the surface tension. So for unknown liquid also we have to W stands for their usual meaning like water. And here is the tabulation. So you have to note down all the readings in this tabular manner. So 0% means only water, then 5% acetic acid, 10% acetic acid, 15% acetic acid, 20% acetic acid, and 25% acetic acid. And this is the unknown solution whose concentration is not known, or whose percentage solution is not known. So in each case you have to find out the density and as well as how many number of drops from the stalgamometer, and then using those data you can find out the surface tension by using this equation. So here is the dummy data as you can see. So let's discuss one, 0% or water. So here weight of solution and bottle in gram is, let's say, 21.29, and weight of solution is 10.13 gram. So density is found to be 1.013, and then you can find out the number of drops for water. So it is found to be average, let's say, 28. So by using this relationship you can find out the surface tension. It is found to be 72.75, and it is constant. So even if you don't need to calculate for water, it is constant. And for other solutions you can find out it similarly. Similarly here unknown solution also, the surface tension is calculated, it is found to be 65. So here you need to plot a graph. So a graph is plotted between percentage of composition versus surface tension. So by knowing the surface tension of unknown solution of a composition of acetic acid, let's say A, so we can determine the percentage of composition. So here you plot the graph between surface tension and percentage of composition. So once you know the surface tension of unknown solution, so now you extrapolate, and where it crosses the line, the percentage of composition, that will be our result. So as you can see here, for unknown solution it is surface tension is 65, let's say. So you plot the graph and you will get a plot like this. So now we have seen for unknown solution 65. So you draw a line parallel to 65, then where it crosses this graph, so now you extrapolate. So it is found to be 8%. So this will be our solution or result. So from the graph, the concentration of unknown composition of acetic acid was found to be 8%. So this is our conclusion. So please subscribe to our channel Chemistry Live UGPG. So this is a simple step towards e-learning, making life better. Thank you all for learning.